Section 2 of National Geographic Magazine, Volume 1, Number 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Marianne. The Rivers and Valleys of Pennsylvania, Part 2, by William Morris Davis. Part 2. Outline of the geological history of the region. 5. Conditions of formation. The region in which the Susquehanna and the neighboring rivers are now located is built in chief part of marine sediments derived in Paleozoic time from a large land area to the southeast, whose northwest coastline probably crossed Pennsylvania somewhere in the southeastern part of the state, doubtless varying its position, however, by many miles as the sea advanced and receded in accordance with the changes in the relative altitudes of the land and water surfaces, such as have been discussed by Newbery and Claypole. The sediments thus accumulated are of enormous thickness, measuring 20 or 30,000 feet from their crystalline foundation to the uppermost layer now remaining. The whole mass is essentially conformable in the central part of the state. Some of the formations are resistant, and these have determined the position of our ridges. Others are weaker and are chosen as the sites of valleys and lowlands. The first are the Oneida and Medina sandstones, which will be here generally referred to under the latter name alone. The Pocono sandstone and the Pottsville conglomerate. To these may be added the fundamental crystalline mass on which the whole series of bedded formations was deposited, and the basal sandstone that is generally associated with it. Wherever we now see these harder rocks, they rise above the surrounding lowland surface. On the other hand, the weaker beds are the Cambrian limestones, Trenton, and the slates, Hudson River, all the Silurian except the Medina above named, the whole of the Devonian, in which however there are two hard beds of subordinate value, the Oriskany sandstone and a Chemung sandstone and conglomerate that form low and broken ridges over the softer ground on either side of them, and the Carboniferous, Mauch Chunk, red shales, and some of the weaker sandstones, coal measures. 6. Former extension of strata to the southeast. We are not much concerned with the conditions under which this great series of beds was formed, but, as will appear later, it is important for us to recognize that the present southeastern margin of the beds is not by any means their original margin in that direction. It is probable that the whole mass of deposits, with greater or less variations of thickness, extended at least 20 miles southeast of Blue Mountain, and that many of the beds extended much farther. The reason for this conclusion is a simple one. The several resistant beds above mentioned consist of quartz sand and pebbles that cannot be derived from the underlying beds of limestones and shales. Their only known source lay in the crystalline rocks of the Paleozoic land to the southeast. South Mountain may possibly have made part of this Paleozoic land, but it seems more probable that it was land only during the earlier Archean age, and that it was submerged and buried in Cambrian time and not again brought to the light of day until it had been crushed into many local anticlines whose crests were uncovered by Permian and later erosion. The occurrence of Cambrian limestone on either side of South Mountain, taken with its compound anticlinal structure, makes it likely that Medina time found this crystalline area entirely covered by the Cambrian beds. Medina sands must therefore have come from farther still to the southeast. A similar argument applies to the source of the Pocono and Pottsville beds. The measure of 20 miles as the former southeastern extension of Paleozoic formations therefore seems to be a moderate one for the average of the whole series. Perhaps 40 would be nearer the truth. 7. Cambro-Silurian and Permian deformations. This great series of once horizontal beds is now wonderfully distorted, but the distortions follow a general rule of trending northeast and southwest, and of diminishing in intensity from southeast to northwest. In the Hudson Valley, it is well known that a considerable disturbance occurred between Cambrian and Silurian time, for there the Medina lies uncomfortably on the Hudson River shales. It seems likely, for reasons that will be briefly given later on, that the same disturbance extended into Pennsylvania and farther southwest, but that it affected only the southeastern corner of the state, and that the unconformities in evidence of it, which are preserved in the Hudson Valley, are here lost by subsequent erosion. A waste of the ancient land, in its Cambro-Silurian annex, still continued and furnished vast beds of sandstone and sandy shales to the remaining marine area, until at last the subsiding Paleozoic basin was filled up and the coal marshes extended broadly across it. At this time we may picture the drainage of the southeastern land area wandering rather slowly across the great Carboniferous plains to the still submerged basin far to the west, a condition of things that is not imperfectly represented, although in a somewhat more advanced stage, by the existing drainage of the mountains of the Carolinas across the more modern coastal plain to the Atlantic. This condition was interrupted by the great Permian deformation that gave rise to the main ranges of the Appalachians in Pennsylvania, Virginia, and Tennessee. The Permian name seems appropriate here, for while the deformation may have begun at an earlier date, and may have continued into Triassic time, its culmination seems to have been within Permian limits. It was characterized by a resistless force of compression exerted in a southeast-northwest line, in obedience to which the whole series of Paleozoic beds, even 20 or more thousand feet in thickness, was crowded gradually into great and small folds, trending northeast and southwest. The subjacent Archean terrain doubtless shared more or less in the disturbance. For example, South Mountain is described by Leslie as not one mountain, but a system of mountains separated by valleys. It is, geologically considered, a system of anticlinals with troughs between. It appears that South Mountain Range ends eastward in Cumberland and York counties in a hand with 5 anticlinal fingers. It may be concluded with fair probability that the folds began to rise in the southeast, where they are crowded closest together, some of them having begun here while coal marshes were still forming farther west, and that the last folds to be begun were the fainter ones on the plateau, now seen in Negro Mountain and Chestnut and Laurel ridges. In consequence of the inequalities in the force of compression or in the resistance of the yielding mass, the folds do not continue indefinitely with horizontal axes, but vary in height, rising or falling away in great variety. Several adjacent folds often follow some general control in this respect, their axes rising and falling together. It is to an unequal yielding of this kind that we owe the location of the anthracite synclinal basins in eastern Pennsylvania, the coal measures being now worn away from the prolongation of the synclines, which rise in either direction. 8. Perm-Triassic denudation. During and for a long time after this period of mountain growth, the destructive processes of erosion wasted the land and lowered its surface. An enormous amount of material was thus swept away and laid down in some unknown ocean bed. We shall speak of this as the Perm-Triassic period of erosion. A measure of its vast accomplishment is seen when we find that the Newark Formation, which is generally correlated with the Triassic or Jurassic time, lies unconformably on the eroded surface of Cambrian and Archean rocks in the southeastern part of the state, where we have concluded that the Paleozoic series once existed. Where the strata must have risen in great mountain mass as a result of the Appalachian deformations, and whence they must therefore have been denuded before the deposition of the Newark beds. Not only so, the moderate sinuosity of the southeastern or under boundary of the Newark Formation indicates clearly enough that the surface on which that portion of the formation lies is one of no great relief or inequality, and such a surface can be carved out of an elevated land only after long-continued denudation, by which topographic development is carried beyond the time of its greatest strength or maturity into the fainter expression of old age. This is a matter of some importance in our study of the development of the rivers of Pennsylvania, and it also constitutes a good part of the evidence already referred to as indicating that there must have been some earlier deformations of importance in the southeastern part of the state, for it is hardly conceivable that the great Paleozoic mass could have been so deeply worn off of the Newark belt between the making of the last of the coal beds and the first of the Newark. It seems more in accordance with the facts here recounted and with the teachings of geological history in general to suppose, as we have here, that something of the present deformation of the ancient rocks underlying the Newark beds was given at an early date, such as that of the Green Mountain growth, and that a certain amount of the erosion of the folded beds was thus made possible in Middle Paleozoic time. Then again at some later date, as Permian, a second period of mountain growth arrived, and further folding was effected, and after this came deeper erosion, thus dividing the destructive work that was done into several parts, instead of crowding it all into the post-Carboniferous time ordinarily assigned to it. It is indeed not impossible that an important share of what we have called the Permian deformation was, as above suggested, accomplished in the southeastern part of the state while the coal beds were yet forming in the west. Many grains of sand in the sandstones of the coal measures may have had several temporary halts in other sandstone beds between the time of their first erosion from the Archean rocks and the much later time when they found the resting place that they now occupy. 9. Newark deposition. After the great Paleozoic and Perm-Triassic erosions thus indicated, when the southeastern area of ancient mountains had been well worn down and the Permian folds of the central district had acquired a well-developed drainage, there appeared an opportunity for local deposition in the slow depression of a northeast-southwest belt of the deeply wasted land across the southeastern part of the state. And into this trough-like depression the waste from the adjacent areas on either side was carried, building the Newark formation. This may be referred to as the Newark or Trias-Jurassic period of deposition. The volume of this formation is unknown, as its thickness and original area are still undetermined, but it is pretty surely of many thousand feet in vertical measure, and its original area may have been easily a fifth or a quarter in excess of its present area, if not larger yet. So great a local accumulation seems to indicate that while the bed of deposition was sinking, the adjacent areas were rising, in order to furnish a continual supply of material. The occurrence of heavy conglomerates along the margins of the Newark formation confirms this supposition, and the heavy breccias near Redding indicate the occurrence of a strong topography and a strong transporting agent to the northwest of this part of the Newark belt. It will be necessary, when the development of the ancestors of our present rivers is taken up, to consider the effects of the depression that determined the locus of Newark deposition and of the adjacent elevation that maintained a supply of material. 10. Jurassic tilting. Newark deposition was stopped by a gradual reversal of the conditions that introduced it. The depression of the Newark belt was after a time reversed into elevation, accompanied by a peculiar tilting, and again the waste of the region was carried away to some unknown resting place. This disturbance, which may be regarded as a revival of the Permian activity, culminated in Jurassic, or at least in post-Newark time, and resulted in the production of the singular monoclinal attitude of the formation. And as far as I can correlate it with the accompanying change in the underlying structure, it involved there an over-pushing of the closed folds of the Archean and Paleozoic rocks. This is illustrated in figures 2 and 3, in which the original and disturbed attitudes of the Newark and the underlying formations are roughly shown, the over-pushing of the fundamental folds causing the monoclinal and probably faulted structure in the overlying beds. If this be true, we might suspect that the unsymmetrical attitude of the Appalachian folds, noted by Rogers as a characteristic of the range, is a feature that was intensified if not originated in Jurassic and not in Permian time. It is not to be supposed that the Jurassic deformation was limited to the area of the Newark beds. It may have extended some way on either side, but it presumably faded out at no great distance, for it has not been detected in the history of the Atlantic and Mississippi regions remote from the Newark belt. In the district of the central folds of Pennsylvania, with which we are particularly concerned, this deformation was probably expressed in a further folding and over-pushing of the already partly folded beds with rapidly decreasing effect to the northwest, and perhaps also by slip faults, which at the surface of the ground nearly followed the bedding planes. But this is evidently hypothetical to a high degree. The essential point for our subsequent consideration is that the Jurassic deformation was probably accompanied by a moderate elevation, for it allowed the erosion of the Newark beds and of laterally adjacent areas as well. 11. Jura-Cretaceous denudation. In consequence of this elevation, a new cycle of erosion was entered upon, which I shall call the Jura-Cretaceous cycle. It allowed the accomplishment of a vast work, which ended in the production of a general lowland of denudation, a wide area of faint relief, whose elevated remnants are now to be seen in the even ridge crests that so strongly characterize the central district, as well as in certain other even uplands, now etched by the erosion of a latter cycle of destructive work. I shall not here take space for the deliberate statement of the argument leading to this end, but its elements are as follows. The extraordinarily persistent accordance along the crestline altitudes of many Medina and Carboniferous ridges in the central district. The generally corresponding elevation of the western plateau surface, itself a surface of erosion, now trenched by relatively deep and narrow valleys. The generally uniform and consistent altitude of the uplands in the crystalline highlands of northern New Jersey and in the southern mountains of Pennsylvania. The extension of the same general surface descending slowly eastward over the even crest lines of the Newark trap ridges. Besides the evidence of less continental elevation thus deduced from the topography, it may be noted that a lower stand of the land in Cretaceous time than now is indicated by the erosion that the Cretaceous beds have suffered in consequence of the elevation that followed their deposition. The Cretaceous transgression in the western states doubtless bears on the problem also. Finally, it may be fairly urged that it is more accordant with what is known about old mountains in general to suppose that their mass has stood at different attitudes with respect to base level during their long period of denudation than to suppose that they have held one attitude through all the time since their deformation. It is natural enough that the former maintenance of some lower altitude than the present should have expression in the form of the country, if not now extinguished by subsequent erosion. It is simply the reversal of this statement that leads us to the above stated conclusion. We may be sure that the long maintained period of relative quiet was of great importance in allowing time for the mature adjustment of the rivers of the region, and hence due account must be taken of it in a later section. I say relative quiet, for there were certainly subordinate oscillations of greater or less value. McGee has detected records of one of these about the beginning of Cretaceous time, but its effects are not now known to be of geographic value. That is, they do not now manifest themselves in the form of the present surface of the land, but only in the manner of deposition and ancient erosion of certain deposits. Another subordinate oscillation in the sense of a moderate depression seems to have extended through middle and later Cretaceous time, resulting in an inland transgression of the sea and the deposit of the Cretaceous formation unconformably on the previous land surface for a considerable distance beyond the present margin of the formation. This is important as affecting our rivers. Although these oscillations were of considerable geologic value, I do not think that for the present purposes they call for any primary division of the Jura-Cretaceous cycle. For as the result of this long period of denudation we find but a single record in the great lowland of erosion above described, a record of prime importance in the geographic development of our region that will often be referred to. The surface of faint relief then completed may be called the Cretaceous base level lowland. It may be pictured as a low, undulating plain of wide extent, with a portion of its Atlantic margin submerged and covered over with a relatively thin marine deposit of sands, marls, and clays. 12. Tertiary elevation and denudation. This broad lowland is a lowland no longer. It has been raised over the greater part of its area into a highland with an elevation of from 1 to 3,000 feet, sloping gently eastward and descending under the Atlantic level near the present margin of the Cretaceous formation. The elevation seems to have taken place early in Tertiary time and will be referred to as of that date. Opportunity was then given for the revival of the previously exhausted forces of denudation, and as a consequence we now see the formerly even surface of the plain greatly roughened by the incision of deep valleys and the opening of broad lowlands on its softer rocks. Only the harder rocks retain indications of the even surface which once stretched continuously across the whole area. The best indication of the average altitude at which the mass stood through the greater part of post-Cretaceous time is to be found on the weak shales of the Newark Formation in New Jersey and Pennsylvania, and on the weak Cambrian limestones of the great Kittatinny Valley, for both of these areas have been actually almost base-leveled again in the Tertiary cycle. They will be referred to as the Tertiary base-level lowlands, and the valleys corresponding to them, cut into the harder rocks, as well as the rolling lowlands between the ridges of the Central District of Pennsylvania, will be regarded as of the same date. Whatever variations of level occurred in this cycle of development do not seem to have left marks of importance on the inland surface, though they may have had greater significance near the coast. 13. Later changes of level. Again at the close of the Tertiary time there was an elevation of moderate amount, and to this may be referred the trenches that are so distinctly cut across the Tertiary base-level lowland by the larger rivers, as well as the lateral, shallower channels of the smaller streams. This will be called the Quaternary cycle, and for the present no further mention of the oscillations known to have occurred in this division of time need be considered. The reader may find careful discussion of them in the paper by McGee, above referred to. It is proper that I should add that the suggestion of base leveling, both of the crest lines and of the lowlands, that I have found so profitable in this and other work, is due largely to a personal conference with Messrs. Gilbert and McGee of the Geological Survey, but it is not desired to make them in any way responsible for the statements here given. 14. Illustrations of Pennsylvanian topography. A few sketches made during a recent recess trip with several students through Pennsylvania may be introduced in this connection. The first, Figure 4, is a view from Jenny Jump Mountain on the northwestern side of the New Jersey highlands, looking northwest across the Kittatinny Valley lowland to Blue or Kittatinny Mountain, where it is cut at the Delaware Water Gap. The extraordinarily level crest of the mountain preserves record of the Cretaceous base-level lowland. Since the elevation of this ancient lowland, its softer rocks have, as it were, been etched out, leaving the harder ones in relief. Thus the present valley lowland is to be explained. In consequence of the still later elevation of less amount, the Delaware has cut a trench in the present lowland, which is partly seen to the left in the sketch. Figure 5 is a general view of the Lehigh Plateau and Canyon, looking south from Bald Mountain just above Penn Haven Junction. Blue Mountain is the most distant crest seen for a little space. The ridges near and above Mock Chunk form the other outlines, all rising to an astonishingly even altitude, in spite of their great diversity of structure. Before the existing valleys were excavated, the upland surface must have been an even plain, the Cretaceous base-level lowland elevated into a plateau. The valleys cut into the plateau during the Tertiary cycle are narrow here because the rocks are mostly hard. The steep slopes of the canyon-like valley of the Lehigh and the even crests of the ridges manifestly belong to different cycles of development. Figures 6 and 7 are gaps cut in Black Log and Shade Mountain by a small upper branch stream of the Juniata in southeastern Huntingdon County. The stream traverses a breached anticlinal of Medina sandstone, of which these mountains are lateral members. A long narrow valley is opened on the axial Trenton limestone between the two. The gaps are not opposite to each other, and therefore in looking through either gap from the outer country, the even crest of the further ridge is seen beyond the axial valley. The gap in Blacklog Mountain, Figure 6, is located on a small fracture, but in this respect it is unlike most of its fellows. The striking similarity of the two views illustrates the uniformity that so strongly characterizes the Medina ridges of the Central District. Figure 8 is in good part an ideal view based on sketches on the upper Susquehanna and designed to present a typical illustration of the more significant features of the region. It shows the even crest lines of the high Medina or Pocono Ridge in the background, retaining the form given to it in the Cretaceous cycle. The even lowlands in the foreground, opened on the weaker Siluro-Devonian rocks in the Tertiary cycle, and the uneven ridges in the middle distance, marking the Oransky and Chemung beds of intermediate hardness that have lost the Cretaceous level and yet have not been reduced to the Tertiary lowland. The Susquehanna flows distinctly below the lowland plain, and the small side streams run in narrow trenches of late Tertiary and Quaternary date. If this interpretation is accepted, and the Permian mountains are seen to have been once greatly reduced and at a later time worn out, while the ridges of today are merely the relief left by the etching of the Tertiary valleys in a Cretaceous base-leveled lowland, then we may well conclude with Powell that mountains cannot remain long as mountains, they are ephemeral topographic forms. End of section 2.